Lesson 32, Confidence Interval Estimation for One Population Proportion. Now, if we're interested in estimating the value of some unknown population parameter, we can conduct a confidence interval estimate. And if this parameter comes from just one population, and the parameter is specifically a proportion, we can use the following as a guide to take us through the steps in the construction of our confidence interval estimate. Now, unless there exists a compelling reason to do so otherwise, confidence interval estimates are constructed using the customary 95% confidence level. Now, after the random sample has been collected and the sample result, x, and the sample size, n, have been determined, the one-prop-zint command on the TI-84 calculator will calculate the confidence interval estimate for one population proportion p. So on the TI-84 calculator, we do this by pressing Stat to do statistics, arrow over to the Test menu. This is where we find all the confidence interval and hypothesis test commands. Arrow down till the cursor is next to one-prop-zint. Press Enter to select. The required input is the data value, x, the sample size, n, and the confidence level. Arrow down to calculate, press Enter, and the resulting confidence interval is displayed underneath the one-prop-zint command inside parentheses separated by a comma. The first number is the lower limit L, and the second number is the upper limit U. The calculator also displays the sample proportion p hat. The TI-84 calculator denotes the sample proportion as p hat equals x divided by n. So the sample proportion is the sample data value x divided by the sample size n, the required input in the one-prop-zint command. So we can look at the calculator screen and use it to give a symbolic representation of our confidence interval. Now the formula that is programmed into the one-prop-zint command on the TI-84 calculator is given here, where the sample proportion p hat is the point estimate of the population proportion p, and the z times the square root of the quantity p hat times 1 minus p hat over n is the margin of error. And adding and subtracting the margin of error to the point estimate produces the interval estimate. Adding produces the upper limit u, and subtracting produces the lower limit L. This confidence interval estimate is constructed using the results of the central limit theorem. This is attributed to the sample proportion, which is essentially a sample mean of data values, where 1 is given to each sample subject that is included in the proportion of interest, and 0 is given to each sample subject that is not. See, the results of the central limit theorem apply to the distribution of the sample mean, x bar. But the sample proportion p hat is essentially a sample mean where we add up all the data values and divide by n the total number of data values, where the actual data values in the proportions are zeros and ones. 1 if we are counting that because it is included in the proportion, and 0 where we're not counting it because it's not included in the proportion. Therefore, in order for the normal approximation to be reasonable, the sample size must be sufficiently large. It's generally accepted in statistics that sample sizes n greater than 30 is sufficiently large when it comes to the central limit theorem. Now, with sample proportions, smaller sample sizes do not produce reasonable approximations. So we will never construct confidence intervals for proportions when the sample sizes are not sufficiently large. This is due to the underlying distribution of the population for which proportions are based on is the binomial distribution, where n is the total sample size, p is the proportion, and x is the resulting random variable or data value. Thus, we'll never be able to make the assumption that the distribution of the population from which the random sample is selected was normally distributed, because with proportions, it's based off of the binomial distribution. So, the confidence interval estimate for one population proportion P is expressed symbolically as L less than P less than U, where L and U are the calculated values of the confidence interval. And after we've expressed the confidence interval symbolically, we can express the confidence interval verbally. The confidence interval estimate for one population proportion P can be expressed verbally as indicated here, using the calculated values of L and U in terms of the issue under investigation. That is, using words of the problem, we can state that the population proportion P is estimated to be between the lower limit L and the upper limit U with 1 minus alpha times 100% confidence. The following examples will help demonstrate the construction of confidence interval estimates for one population proportion.